Exercise 3 is very straightforward. We are asked to write a C program that asks the user for an integer. We've done that many times using scanf, providing the address of this integer, as you can see here. Next, we are asked print the address, value, and size in bytes of this integer. We print the address using the ampersand operator. If you remove this cast to void star, this will work just as well. Some C compilers want you to explicitly cast this to a void star data type. What this means is this is a generic pointer. So void star can be interpreted as a generic pointer, a pointer to something, we don't know to what, but mostly important that it's a pointer so that it contains a memory address so we know the size. So we can use void star cast for any data type. And so since we're just printing an address and we don't care about the type of the address, we're going to cast to void star. That's not important. The main importance here is that you realize you use the ampersand operator if you want to print the address. You use %p to print the address as a hexadecimal value. Next, you can print n, the value of the int. That was the next instruction, print the value of the int that you scanned. So we just print with %i, we just print the value of n. And lastly, they ask us to print the size in bytes in memory of that integer. For this, we simply use the size of function. Second part of this exercise, store the address of this integer in a pointer, and then print the address value and the size in bytes of this pointer. So that's what we do here. We define a pointer by using this int star as a data type. The star is attached to the name of the variable. P is a pointer. In this pointer, we store the address of n by using the address operator, the ampersand. So we store the address of n in the pointer p. And then we will print the address of the pointer. Now, keep in mind, we don't want the value of the pointer. The value of the pointer is the address of the thing that it points to. But the address of the pointer is a different address. A pointer also has its own address associated with it. And we can ask for this address with the ampersand operator. Just like we can ask for the address of an integer, we can ask for the address of a pointer as well. A pointer is also some memory location. So we ask for the memory address of the pointer, and we print it as a pointer, as a hexadecimal value since it's an address. We ask for the value of the pointer, so we just print p, the value, not the address, just the value. We also print this as a hexadecimal value. Why? Since a pointer contains an address and we print addresses as hexadecimal values. And lastly, the size of the pointer, in bytes, we just use the size operator on the pointer once more. Let's execute this on my machine. You see exercise 3. Let's see, exercise 3. Let's run. There we go. Enter number 2. Address. This is the address. This is the value and the size. And then we have the address of a pointer, which is a different address. But the value of the pointer is indeed the address of our integer. That was what was instructed. And as you can see, I have a 64-bit machine. My pointers are 8 bytes in size.